Hello everyone, welcome back again. My name is Jesse, and in this one tutorial, we're trying to see how to do test classification with Python, right? So we'll be using Sklearn and Spacy to help us with our test classification. Then after that, we are going to interpret that model that I'm going to build with Eli5. So the step is that we'll be trying to process our test with Spacy and in Python itself, and then we'll be trying to build our model and classify our test, which is some interesting tests with sentiment analysis with Sklearn, and then we are going to interpret it with Eli5. Right? So that is the basic idea. So this test classification here is going to be like sentiment analysis, positive or negative, not necessarily group of stuff. So now let's see. If we load our EDA packages, this pandas and NumPy, then we load our NLP packages as Spacy. Then we're going to create a Spacy object with this particular stuff, and then we need to get the stopwares, right? So we'll be using Spacy to do pre-processing. So we'll use the Spacy's stopwares to remove all the stopwares. Then also going to import punctuations to allow us to remove all the punctuations. Let's build a simple Spacy parser. So this is going to be an empty parser for English because we are working with an English test. Then the next thing we're going to build our stopwares. So this is going to be our stopwares. So it's going to be a list of stopwares which is coming from the Spacy stopwares that we imported, right? So let's see the list of our stopwares that we have. So stopwares going to be a list of them. Very interesting, right? So these are all the stopwares that we have. So we want to be able to remove them. So we have a word like may here, all of these are stopwares. So perfect. Now let's build a tokenizer which is going to tokenize them, right, with Spacy. So we are going to create a Spacy tokenizer. So we're going to pass in our sentence. We're going to limitize them, strip all white spaces, put them in lower cases to build our first token. Then we're going to run the stopwares to filter out all stopwares and punctuations with this particular function. Let me create a size. I think it's better, right? Or let's go back to the normal. Okay, perfect. So that is something simple that you are building. So let me run it here. Now let's try a simple example and see whether our function is working. So I'm just going to pass in this particular example. So he was working with the worker in a wall, and then he may had to sit, right? He made something. He may had sat. Good English. Okay. So something like this. So this is a simple sentence. So let's see whether we can be able to work with our Spacy tokenizer that we created. If it's going to work. So this is going to pass in a Spacy tokenizer, and I'll pass in my example 1. Perfect, right? So that it's able to limitize it, tokenize it, remove all unnecessary stopways. So he was stripped out, right? Because you can see a lot of repetition of he. Worker. So working was stripped to work. Wall is okay, was normalized to from capital to small. Sat was made to sit. Then runner and runner, right? So it has been able to tokenize this entire sentence in a very way. That means our Spacy tokenizer is working. Now let's see how to work with our ML package. So I'll load my ML packages, which is going to be all of these packages: feature extraction to do factorization. You're going to import accuracy. You're going to import transform this to transform them. You're going to import pipeline to import pipeline, and then you're using SVM, right? So SVC, support vector machine. That's what we're using for our ML packages. So for interpreting it, as we already said, we're going to be using Eli5. So import Eli5. So we are going to import all the things that we need before. Now let's see how to work with it. So I'm just going to import Eli5 too, and let's work with it. So these are datasets which I've already cleaned, right, to make it easier, faster. It's easy when you have a clean dataset. So just go to dfs, go to pd.read_csv, go to read our dataset which we have. When we read our dataset, let's check for the first row. We have our Yelp, right? This is a combination of Yelp and then several of them. So we have Yelp, we have the number, and then this is the message, and then the target. So the target is going to be our particular label, right? So 0 means it's negative, and then 1 means it's a positive. So crash is not good, it's a negative sentiment or negative polarity. So let's check for the shape of our data set, which is about 2745 data sets. So that is what we'll be working with, right? Perfect, in a very simple, nice way. So let's check for the columns. So if you check for the columns, you have to move all of these things out, right? And then use this message and then tag. That's what we're doing. Now let's create a simple class to help us transform our dataset using Space, right? So this is something very simple and very basic, and it's quite explanatory. So let's build a simple predictor function. We're going to also create a simple clean test function, which we may use, right? So after that, we're going to create our vectorization. So we're going to create our vectorizer. So we're going to using count vectorizer. Then we're going to pass in our Spacy tokenizer that we created above, and an n-gram range of 1:1, right? That is a unigram. Then we're using our classifier, so you can use linear support vector, which is going to give you a very good accuracy. Then we're using support vector machine, which we imported from here, right? SVM, we're using SVC from it. But when you are working with it, it is not that very accurate because you're supposed to do some tweaking to make your model to improve the accuracy of your model. So that's why I'm putting C as 50, gamma of this, and then probability set as true. It's very, very important, right? Because you're working with test data. And for the Eli5 to be able to explain it well. Perfect. Now let's build another one for our 10 frequency vectorizer, which we may not use, but we can use, right? Anyway, and let's split our data set into train and then target. So we're just going to import train test plate from here, and then we're going to build our data set, right? Our features. So the S is going to be for our message itself, that is our features. Then the Y is going to be for our labels, right? And let's split our data set into S train, S test, and Y train, Y test. Then let's check what our S train has to offer us. So these are all the values for the S train, which is very interesting, right? So if I check for the shape of this, or the size of it on the shape, so let's say S train dot shape, so it's about 2196, right? Out of the 2070 something, 2700 something. So this is very interesting. We'll be working with it. Now let's build a pipeline that's going to do all of these tasks we're supposed to do, to clean it, to normalize them, to build our model, so that it becomes easier and then faster for us. So pipeline, then we're going to pass in our cleaner with our predictors, which we created here to do our transformation and then our fitting together. Then we use our vectorizer to vectorize it, then use our classifier to classify it. So we start with, we clean it, we vectorize it, then we build our model, we vectorize it, then we classify it, right? So that's the pipeline. Now you need to feed it some data, right? To be able to build an arrangement, build a relation between our S train and our Y train with a pipe fit, which takes some time to fit our data together. This is our pipeline that has been built, so that if you check for it, you can see all of those things. Our vectorizer, count vectorizer, our cleaner, predictors, and then probability set it true. All of these things is working perfectly. Now let's see the shape of our S test that we had. This is the shape of our S test. Now let's see the first value of what it is and see whether it's going to work. So this is a true classic. So is it a positive sentiment or a negative sentiment? So we'll try and analyze it. Right. So let's try it and see and predict. See, so sample prediction is going to predict pipe.predict to see whether it's going to give us a good prediction. So this is going to give us for all of them. It is quite huge for all of them, right? And then these are 101, which is not that bad for all of them. So this is for all of them. Now let's check for the accuracy of our model. So if I check for the accuracy, pipe.score, the S test and then Y test. Let's see how much it's going to give to us. Not that bad. So 75%. Not that bad, right? It's a good. At least we are always expecting 90, but this is test data, so 75. Not that bad. Okay. Now let's see some other things you can also do. So to make it easier, so let's create a sample stuff. So remember that 1 is positive and 0 is negative. So we want to see what is predicted. It takes some time to run. So great pop is positive sentiment. It's a true classic. It's 0, because this the reason I think it's giving us 0 is that it's a true classic. It's not a positive sentiment, neither is the negative. It's just there. Right? That's why I believe it gave us as negative sentiment. But we will analyze it later and see why. So we love biscuit is a good prediction of 1. It's not that bad. So most of these predictions are accurate, others are not that accurate. But we take it like that because it is 75. So now we are going to use Eli5 to explain why some of them are 1 and why some of them are 0, why some of them are positive with you and why some of them are negative with you, right? Perfect. So that's finished. It's quite a long stuff, very, very long, right? So very, very long. Now let's see how to explain our model. So interpreting our model, don't know whether that is how to spell interpret. Text is supposed to be interpret, right? Something like this. Anyway, okay, interpreting our model. So we're using Eli5 to do that. So to do that, first of all, Eli5 also has some interesting packages. So we have the basic ones of the show weight and then the show predictions. But in case you are working with tests, right, you can import test explainer, right? So Eli5 support line, that is local interpretable model agnostic package. So it supports the test explainer from line. So you can just import that one to enable us to work with our test data. So from Eli5.line import test explainer. Then we see that this was our prediction function that we had, right? So when we are working with line, we have our data, our prediction function, and then our labels, right? Our feature names and our class names. So we need to check our prediction probability. So let's create our explainer, right? So this is going to be an explainer, then test explainer. We want to initialize at a random of 4. Then let's see the test that we want to predict. So this is a true classic, right? But let's change it and let's give it something like let's give it the first one, the first value, which we know that is a positive sentiment. So great pork sandwich, right? Great pork, which is a positive prediction, right? So in case we are supposed to predict this one, it's going to give us a positive prediction, because from here we realize that if you check from here, I don't want to run it again. This was 1, is positive. Let's check it from here. That great pork is 1, right? It's a good review, it's a positive review. So let's analyze why it's a positive review, right? Or let's go with 1, 2, 3, 4, 5. So with 5, we love the biscuit. Let's see why it's a positive sentiment or positive review. So put it in the head again. So now let's try and see how it's going to be. So first of all, we're going to explain it. So explain.fit, going to fit that particular value that we have, which was 0, not 1, because we are changing it, right? Then with our function. So this is our value, our data that you are predicting, and then our prediction function, right? Take some time to run based on how fast the system is. Perfect. So it has built our explainer, right, with all of these things. So this is quite a lot of stuff. So this is self-explanatory. Now let's move on and build our target name. So because we need to be able to see what is producing. So we need a target name, and then we need our data in our prediction function. So let's go with, you need to get all the names. We have 0 and 1, but 0 and 1 is not that explanatory. So let's give it a particular name. So 0 is negative and then 1 is positive, right? So that's going to be a target name. Then I'm going to go with explainer or explain.show predictions, right? Then my target name. So in the previous one, in case we were working alone without test, this was going to be, it's going to be our Eli5, right? Dot show predictions. Right? If you're not working with the test data, it have been like this, then we're going to give our model, right, and we're going to explain it, and then whatever data you want to provide. But because we are working with this test, we have to go in a particular format. So this is going to be our target name, so that we're going to explain it very well. Perfect. So this is the data that we have, right? So this is the stuff we have highlighted in test. So the highlighted in test is a particular contribution. So this particular stuff that has been highlighted is contributing to give us that positive polarity, right? So let's see it well. So I'll change it to white so that we see it well. Okay, back to it. So now you can see it better. Okay, I think this is better. So we have this positive polarity or positive prediction, right? That is a prediction that it's able to give to us, and it's giving us a probability of 0.85. And why is it giving us this positive sentiment or positive review or positive prediction? The reason is that this test here, the grid here, that is the explanation. The grid here is contributing 1.85% of its weight to give us this prediction. Very, very interesting, right? So it is quite interesting. The color is green and the color here is also green. So that is the highlighted test that is giving us that contribution. So with that, so by that particular word grid here, it is giving us this prediction. Very interesting, right? So this is how to able to give to us. So how can you trust this, that this is giving us the actual stuff, right? So let's see. To trust it, just go with the metrics. So es.metrics, Then the ES matrix give us two options, giving us the MLK-KL divergence, which must be 0. If it's 0, that means that's a perfect match. And then 1, right? And then the score of 1. So the score is an accuracy score weighted by the cosine distance between the generated sample and an original document, right? So if this one is 0.0, that means that's a very, very good match. It's a very, very good probability. It's almost 0. So that means that the divergence is very good. So the explanation can be trusted, right? If it has given us something different, then this explanation cannot be trusted. So this is the metrics to check about it. Apart from that too, you can also show the weights with this particular stuff. So let's say ESP show weight, and then it's going to give us the show weight, right, for all of this. And so this is the weight for all the weights. So great is contributing so much to it. Then we have pork, great pork, combining them like n grams, right? Then pork sandwich, then it's going to divide it individually. Local, just like lime, it's using just like lime's algorithm. So local, so great to score it, great pork to score it, great pork sandwich score it, pork sandwich like that, like n grams. Very interesting. So that is how to work with this particular package. So it gives you a lot of stuff that you can do in this. So that is something very interesting. So there's some other stuff you can also do. You can also do ESP to see the kind of vectors that was used, to see the kind of classifier that was used. You can just go with vec this, and it's going to give you the particular kind of vectorizer data. So realize that we were using count vectorizer from the beginning, right? So when you use it, give us a particular vectorizer we are using with some explanations. Then in case you also want to check for the particular kind of classifier that it was using, and just do the same thing as CLF, right? Then with the bar, right? Then it's going to give us a particular classifier, SGD classifier. So very interesting and very, very informative. So the basic idea is that, let's go back to our black. So the basic idea is that you build your model, you do whatever you want to do. Then in case you are working with tests, you have to import that test explainer, right? And then you, from Eli5 Lime, a Lime support for Eli5. Then you need some three things. What you need is that you need your data, you need your model, you need your target name or your feature name or your class name. Then you also need your function to do the prediction, right? So these are the three main things that you need, right? Perfect. So we have our data already, then we have our prediction function, then you're going to create our explainer, right? So this is going to be our explainer, then the particular data that you'll be predicting on to explain it, then we're going to fit the entire stuff there, the particular stuff in this option. Then after that, you're just going to create our target name to be able to make it easy for you to understand, right? So this is going to be our target name. We supply it into our prediction, because if you go without the target name, it's also going to work, but it's not going to be more informative. So let's try that one. It will not be more informative. So if I go with this, so that it has worked, we say that with this particular option it gives us y is equal to 1, right? So what is 1? We don't know what 1 is, but because we give here, we supply the target name as positive, right? Here we supply the target name, it's able to tell us precisely what y is, what our prediction is, right? Which is different from this. That's very interesting. So the color is also very important. So the color green is telling us the particular kind of word that contributed to give us this particular positive prediction, right? Then in case you want to be sure that your prediction is actually correct, you can also trust it with the metrics. It will give us the KL divergence and then the score. So if it's closer to 0, that means it's a perfect probability score. It's very accurate, very interesting. Then in case you want to show the weight of each and every word and how it contributed, you can also use this option, right, with the show weight. Then in case you want to check the particular vectorizer, just go with vectors. Then in case you want to check the particular classifier use, you can also use CLS. Thank you for watching this long tutorial. I know I was rushing, but I hope you have learned something. Please don't forget to subscribe and share. Thank you, and stay